Hello students, welcome back. So now I'm going to show you how to get data. There are two main libraries that I use very often to get data. One of them is a scikit-learn and the other one is Seaborn. So make sure just install this library. If you don't have this library, just go ahead and run this command and that's going to install these two libraries. And then I'm also importing my pandas. Pandas I'm importing so that I can save my data in a CSV file. That's the purpose of my pandas. So let's start with scikit-learn package first. First, I'm importing my scikit-learn.dataset as DS. DS is a short for dataset. It's basically creating an alias. I'm creating an empty list. This list is going to hold the name of all the data files that's available. So I'm iterating through this DS, that would be this right here. I'm going through each one of them and I'm checking if any one of these files has a name load underscore, or if the name starts with fetch underscore. I'm going to put that name of the file. I want to append that inside this all data set. That's what this is doing. At the end, I'm printing out all my data set. So in this case, you can see that there's a fetch 20 news group, fetch 20 news group, vectorize. You have all this data set that's present inside your scikit-learn right here. So the commonly used data set is a load one. Anytime when you see load underscore, you're going to see there's a load underscore digits, load underscore diabetes. Also, you're going to see this fetch underscore, fetch underscore. So there's a little difference between them. Your load underscore data set, they tend to be very small and they tend to be toy data set, and these often they come bundled with scikit-learn. In other words, you don't need any internet connection over here. So these are some of the example of your load data set. Then you have fetch underscore data set. These are very large. These are your real world examples, and these they require internet. So these are downloaded from the internet. For example, your fetch 20 news groups, fetch 20 news group, vectorize, fetch California housing, all this thing you get it from the internet. So now let's look at one of the dataset detail. Suppose I want to import iris. That's the one I'm going to look at, load iris. So import your load iris and initiate your instance. So this actually creates your load iris dataset. Now, if you want to access all the attributes of your iris, you can do that by keys. Keys stores all the attributes of your iris dataset. You can see that there's a data, there's a target, frame, target name, description, the feature name, file name, and data module. The important ones for our purpose is these ones right here: data, target name, description, and feature names. So let's look at iris description right here. So I print out the description and that tells me a little bit about iris, what dataset is all about. It's an iris plant dataset. It tells me the characteristics. There are a number of instances. In this case, it's telling me 150. In other words, there are 150 rows. There are 50 in each of the three classes. So that tells me that there are three classes over here. And in this case, four of them are numeric. That means the four columns that you have, they are numerical in nature. And it tells me the column names over here: sepal length in centimeters, sepal width is given in centimeter, petal length is given in centimeter. It also tells me the class. So that tells me that this particular dataset is used for classification purposes. So these are the three different classes that dataset has. This tells you a little bit summary statistics. For sepal length, the minimum value is 4.3, the maximum is 7.9. It also tells you the the mean, standard deviation, and the class correlation. So it gives you a lot of like a summary of your data set right here. It also tells you a little bit about who created this. So it gives you all this information. All right. So let's look at this data. So I want to look at the first 10 rows. So iris.data colon 10, that's going to print out my first 10 rows. So these are my first 10 rows of my data right here. Now I want to know what each one of these values represent. Like this one, what column is that? For that, you can do iris.feature names. That's going to print out column names or feature names for each one of these values over here. So for example, the first one, this 5.1, 4.9, 4.7, all these values, they are your sepal length. The next one, which is 3.5, 3, 3.2, 3.1, 3.6, all these they are your sepal width. And likewise, then you have petal length and petal width. The fourth column right here, that will be your petal width. Now let's say you want to look at the target. So let's say you want to look at the first 10 values of your target. So you do iris.target and then you put colon 10, and that's going to print out the first 10 values. So you have 0, 0, 0 like this. So this one right here, okay, this one actually has a target 0. For this one, the target is 0. So this way you can map each one of them. Now this 0, 0 may not make much sense to you. So there's a attribute called target names. that's going to give you the actual name of each one of them. So when I run this, when I print out this, it's going to give me Setosa versicolor virginica. What it means is that your 0 is Setosa, your 1 is versicolor, and your 2 is your virginica. So anytime, anywhere that you see 2 2 or 1 1, that would mean 1 2 would mean virginica and 1 would mean versicolor. In this particular instance, all of them are 0. The first 10 are 0. That means the first 10 records are for Setosa. So now we are going to save it in a CSV file. So step one, put the data in a data frame. So I'm calling my data frame, and in this case, I'm supplying my iris.data, and I'm supplying my columns. Columns is iris.feature names, and then I'm printing my first 10 samples right here. So you can see that it prints out sepal length, sepal width, petal length, and petal width. It stored the data over here. I also want the target over here. So let's say you want to store the target. So I'm creating a new column called target. That will be iris.target. So this is stored over there. Now after this, I print out my DF sample again, and now you can see that your target appears over here. So the first one right here, this one, that's the target is 0. For this one right here, your target is 1. All right, and I also want to print out, let's say you want to print out the species name. You want to see what the target names are. You can create a column called species. In this case, df target dot apply. And in this case, what you're doing, you're just adding, you're actually applying a lambda function, and it's mapping this 0 to Setosa, 1 to, like if you recall, I think 1, if my memory serves me right, was Virginica, and or versicolor, one of them. And this particular function will take care for you. So it's going to go through each one of them, and whichever was 0, that will be assigned that particular target, and whichever was 1 will be assigned to that target, and likewise your the number 2 will be assigned to that one. Okay, so after I do this thing, I print out the sample again, and now you can see the species column is right here. So 0 is Setosa, and your 0 was all assigned Setosa, your 2 was Virginica, and like you can see that 1 is all versicolor right here. Okay, and then you can save it in a junk file. So in this case, I'm just saving it in a junk iris.1cs.csv, and that actually saves it over there. Now I do not want index over there. Index are these numbers right here, 31, 32. I don't want to print these values in there. So I'm just saying index equal to false. And this way it saves it in a CSV file. So now let's go and take a look at that file. So just come over here, and you're going to see that file, the one I just created, that would be junk iris1.csv. That would be this right here. So right click over here, open up with your notepad, and you will see the records right there. Okay, so these are all your records for this one right here. Let me just increase the size of the screen so it's a little bit more visible. All right, so you can see that sepal length, sepal width, and you have all this data right here. It has saved into CSV file. This is how you can actually get data from your scikit-learn and save it in a CSV file. Now I'm going to show you how to get data from the Seaborn library. Import your Seaborn. That's the first thing you do. And then in this case, from the Seaborn library, I'm calling this function get dataset name. That's going to print out all your dataset names right here. So you can see there's the Anagrams, Anscombe, Attention, Brain Networks, Car Crashes, Diamond. There are so many out there. So in this case, I'm going to stick with this iris just to show you how exactly it looks like. So in this case, sns.load dataset iris. And in this case, all you have to do is just type df2csv junk iris2.csv, and that's going to get saved over there. So after I run this thing, you are going to see a file called junk iris2.csv. So come over here. So let's just open that file up, junk iris2. That would be this right here. And right click, edit in notepad, and there you go. So this is the data right here for that data for this particular iris, and you can see it's a little bit different. This one has sepal underscore length, sepal underscore width, petal underscore length, and petal underscore width, comma species. This is how it looks like in your Seaborn library. Then you can let's say you want to do another one. Let's do this one, sns.load dataset planets. So in this case, I'm saving it in junk data2.csv. So I ran this cell, and let's just go take a look at that cell. What's inside that junk? I think this is junk data 2. So that would be this one. And right click, and let's go to edit in notepad, and let's take a look. Method, number, orbital, period, mass, distance, year. So it basically tells you this is the data about planets, and that's all it tells you. All right, so I hope this session helps you, and now you know how to get data from the Seaborn library and also from the scikit-learn, and you can play around with this data, and you can save it in a CSV file.